We write a function that determines whether the values of an int array can be placed into two bags whose sums are equal. For example, for array B containing 3, 1, 5, 4, 1, 2, we can place them in two bags, 3, 5 and 1, 4, 1, 2, which both sum to 8. But putting the values 4, 2, and 1 into two bags will always yield a bag with an even sum and a bag with an odd sum, because there is only one odd value. Now, look at the specification of split. The spec doesn't require us to construct the bags and data structures. We need only calculate the sum of the values in each bag, not the bags themselves. This will simplify everything tremendously. Function split has only array B as parameter, so we have to think of writing another function that will have more parameters and be recursive. We envision a recursive function in which at each step of recursion, one more value is put into one of the bags. This leads us to the specification shown. Values in B from 0 through k-1 have been placed in the two bags, and their sums are in parameters S1 and S2. Return true if the rest of the array values starting at bk can be placed in the bag so that their sums are equal. Otherwise, return false. With four-parameter method split specified, we can complete the original method split with the body that indicates that no values have been placed in the bags, so the values in the two bags sum to 0. At this point, stop and study the specification of the four-parameter split carefully. Make sure you understand it, as well as the call on it in the one-parameter function split. We're now ready to write the recursive method split. The base case is easy. If k equals b.length, then all the values have been placed in the bags, and true or false can be returned depending on whether the two bags have the same sum or not. For the recursive case, we have two choices. Place b sub k in the first bag, and place b sub k in the second bag. Which one do we do? Well, it really doesn't matter. Suppose we call the first choice, put b sub k in S1. If this choice returns true, true can be returned. But if this choice returns false, the other choice must be called and its value returned. Thus, we write a single return statement, which returns the value of the first one or the value of the second one. Note, if the first one returns true, short-circuit evaluation means that its value will be returned without calling the second one. But if the first one returns false, the value of the second one is returned. Isn't that a neat little algorithm?